Hello everyone, today we're going to look at usaco-training score inflation. Okay, so in this problem we're given that we're supposed to create a usaco contest, which it consists of m minutes, and then there are m problems or m problem categories, where each category has the number of points it's worth and the number of minutes it takes for the problem to be solved. Okay, so like when we construct a problem or a contest, we're going to use several problems such that the sum of those minutes do not exceed m, and the number of points or the sum of the points are as maximum as possible. Okay, so in this example, we're given 300 minutes, and we're given 4 types of problems. Okay, so the first type has 100 points and it takes 60 minutes to solve. The second type is worth 250 points and takes 120 minutes to solve, and so on. So then the best solution would to be taking 2 problems from here and 3 from here. And this would result in, as you can see, this times 2 would be equal to 240. And if we use 4 of these, then it would sum to 300. I mean, actually, if you use 3 of these, then the number of minutes would sum to 300, which is fine, and the number of points would be 605. Okay. So what we can do here is that we can apply dp knapsack to this. So dp of I will be equal to the maximum sum of points such that the number of minutes is I. So for example, the answer for our problem for the sample case would be it would take 300 minutes and the points would be 605. So in this case, we would transform it into dp of 300. This would be equal to 605. As you can see, this is the number of minutes and this is the points. Okay, so originally you know that there's there's 0 points for a sum of 0 minutes. Okay, so now what we can do is that we can basically insert each problem. So for example, you know that we have 160 to 50, 120. Okay. So then what we can do is that we can loop through each of these from top to bottom, and actually it doesn't matter which order. But what we're going to do is that we're going to increment each dp by the number of minutes. So for example, then after the first operation, dp of 100 would be equal to 60. I mean, actually, it would be dp of 60, which would be equal to 100. So 60 would be equal to 100. And then, since you can actually use a problem or many problems from a single category, you'd also set dp of 120 equals to 200, and dot 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 until you have like dp 300 would be equal to 500. Okay, so this is after using this. So now we're done with this. Okay, so now let's just say we're doing this. Okay, so Again, you know that it takes 120 minutes, so after this, you would set dp of 120. Since you have this in the beginning and you see that 250 is greater than 200, then you would set this to 250. And again, next thing you would do is you would set dp of 180 to 120 plus 100, so this would be 220. And as you can see, this would correspond to this. So what we can do is that we can keep track of just one array, and we wouldn't reset it every single time. So you would just keep the values you had before. So the pseudocode would actually look something like this. So you know that dp of 0 will be equal to 0. Okay. So basically now for each point and minute in types, so each problem type, we're basically going to loop through each minute. So basically for I in range, it would be in range the number of minutes, or the number of minutes it takes to solve this problem, and the total number of minutes. Then dp of I, since you want the maximum, it would be equal to the max of the original one. Oops. And dp of I minus m plus point. And because using this specific problem type, it takes m minutes, so dp of I will be equal to dp of I minus m, since you're basically subtracting m from it. And then you add p points because using this, using another problem would gain you p points. And then our answer would just be the maximum of dp of I. So basically be the max of dp of I. Okay. So this is square inflation. Okay, so let's include bits. So we're given a number m, the number of minutes, or the length of the contest, and n. So let's read those. Okay. So now we know we have to have our dp array. So we can have int dp, and the total number of minutes is going to be 10,000. So let's just give it a 5. So now that dp of 0 is equal to 0. So now for each type of problem, we're going to have the number of points and the number of minutes. So let's read those. So then, again, as I said before, we're going to loop through each j from m to the total number of minutes. So then dp of j would be equal to the max dp of j, or its original value, and dp of j minus m plus p. Okay, so as I said before, it takes m minutes to learn this, or it takes m minutes to solve this problem, so then you would take this away from the total time and you would add the number of points. So then we can have our answer. Now you just take the maximum of all the possible ones. So answer would be equal to the max of answer in dp of I. So let's just print answer. Okay, so this is usaco-training. Oops. And this is score, inflation, and here I ran it. Okay. So okay, so it's actually should be I over here. Okay, 605, which is correct. So let's actually submit it. Okay, inflate that out. Okay, so this is in the language. Okay, so let's submit it. Okay, so usaco-training score inflation. Okay, so that is right. So if you have any questions, feel free to leave them in the comment section below. Thank you. Bye.